Okay, we're continuing with lesson 10, and they call this, let's see, what do they call it? Rational denominators. They say, you ever see this? I don't know if we talked about this in here or not, but I'm just making this up, right? You ever see anything like that? Yeah. Um, a lot of times the books say that this is not simplified. I really don't know why it's not considered simplified. um, looks pretty simplified to me, doesn't it to you? I mean, because you can't do anything with a square root of 2, but the books say that this is not simplified because there's a square root in the denominator. You ever heard that in algebra? Probably algebra 2. You probably covered that stuff. So what they say is they don't want a square root in the denominator. Again, I don't really know what the reasoning is behind that. I think somebody might have explained it to me at one point, and I just forget. But anyway, that's what books do. And a lot of teachers, if you go to college, you might have a teacher that makes you get rid of the square root in the denominator. And it's not just a square root, but it's any root. It could be a cubed root, a fourth root, anything like that. Okay, so what we want to do is we want to get rid of that square root that's in the denominator. Okay, we call that rationalizing the denominator. Rationalizing, okay, the denominator. And I'll just shorthand it, denominator. You can write that out if you want. All right, so how in the world would we get rid of that square root? Well, let's backtrack a little bit. What if I asked you to do this? What if I said, what is the square root of 3 times the square root of 3? We've talked about that in this class, okay, where you should just be able to look at it without doing any math and just seeing what this is equal to. And Daniel said it is just 3. Well, how did he get 3? Well, because there's a rule that says when you multiply square roots together, you can make it one big square root and just multiply those numbers and stick it inside of there. All right, so I have a square root. I got 3 times 3, which is 9. What is the square root of 9? It's just plain old 3, isn't it? But instead of going through that process the whole time, you just look at it. Look, a square root times itself, basically what am I doing? Basically just squaring it, aren't I? All right, that gets rid of the square root, so I'm just left with what's underneath of the square root, which is a 3. You could do that with another number. I'm just picking arbitrary numbers here. Square root of 7 times square root of 7 without doing all the math. What is that? It's 7, right? You could have gone 7 times 7 is 49. What's the square root of 49? It's 7, right? You could have done that. But what if you did this? What if I said, what's the square root of 17 times the square root of 17? Most of you probably can't do 17 times 17 in your head, and even if you could, taking the square root of it, you may not know what it is, but after you see this little pattern, what is that? It's just 17. Now watch, here's one that you definitely probably couldn't do in your head. I'm just making this up. Square root of 257 times square root of 257. If I do that, what do I get? 257, okay? I don't have to be able to multiply those together. I don't have to be able to take the square root of either one of those, do I? I just know that when I take a square root, multiply it by itself, it's just that number inside the square root. You got it? All right. With all that said, let's go back to this. What I want to do is I want to get rid of that square root. I don't necessarily want to get rid of the denominator, but I don't want that to be a square root anymore. So what I'm going to do is I'm going to multiply the bottom by something and the top by the same thing. Now, what would I have to multiply this by in order to get it to be a nice whole number? Look what we just did right here. What did I multiply square root of 3 by in order to get it to be a whole number? Square root of 3. What did I multiply the square root of 17 by in order to get it to be a whole number? Square root of 17. So, if I want to get rid of the square root of 2, what do I multiply it by in order to get rid of that square root? Square root of 2. Good. So I've got a square root of 2. Now watch. I multiply the bottom by a square root of 2, and I also multiply the top by the square root of 2. Now why did I do that? No, that's not really the reason. Okay, a lot of people say that. It's not because whatever you do to the bottom, you do to the top. That's left side and right side. Okay, whatever you do to the left side, you do to the right side. It's really not the reasoning here. I put this in red for a reason. Look, square root of 2 over square root of 2. What's anything divided by itself? It's a 1, right? What do I do when I multiply something by 1? Does it change the value of it? Doesn't at all. So really, it's not because whatever I do to the bottom, I do to the top. That's not the reason at all. That's not a valid reason. What I've done here is I've multiplied it by a 1, and I can multiply anything by a 1. Make sense? Okay, so let's keep on going. Let's see what we're going to do. Remember, the whole idea of this, they say to simplify. That's what they're telling you to do. So it's not simplified. Why is this not simplified? Because there's a what? Square root in the bottom, right? So I want to rationalize the denominator, and I multiply the top and the bottom by the square root of 2. Technically, I'm just multiplying by a 1. Is really all I'm doing. So let's do the bottom. What is the square root of 2 times the square root of 2? It's a 2. That's the whole reason that I multiplied by a square root of 2. Would you agree? So that it got rid of the square root. Got rid of the square root where? On the bottom. Okay, you can't have a square root in the denominator. All right, I can have one on top, that's fine. For some reason, they just tell us, whoever made up these rules told us that you can't have it in the denominator. So let's look at the top. What's the top going to be? It's just going to be 5 square root of 2. All right, and that's all you can do with that. It's not square root of 10. All right, so don't do that. Don't go 5 times 2 because this is just a plain old number 5. This is a square root of 2. The only thing I can do is write it 5 square root of 2. Make sense? Now look, does this 2 cancel out with this 2 right here? No. Why not? Because that's not a square root, right? This is a square root of 2. It's a completely different number than 2, isn't it? So I can't cancel that out. That's how I would simplify that fraction right there. Make sense? Okay. That's kind of like the easy version of that. All right, they pump it up a little bit on this. Here's the example that they give in the book. This is example 10.4. 10.4. Okay, and here it is. It's 4 plus square root of 3 over 2 minus 3 square root of 3. Now we're going to have to do a little background. You know how we did this little background stuff over here in order to understand what we were supposed to do here? We're going to do a little bit more with this. All right? Let me get rid of all this mess. Give me some room to write. All right, we'll come back to this in a second. All right? Let's just backtrack a little bit. This stuff you probably learned back in Algebra 2, probably. I doubt you learned it in Algebra 1. You probably learned it in Algebra 2. Watch this. What if I... Now, first of all, why is this not simplified? Because you got a square root on the bottom. That's right. Okay, so you'd think, okay, well, what do we do? Just multiply the top and bottom by the square root of 3, right? Well, this is a little different because look what you have right here. You got a minus. When you have a minus or a plus in between, I'm not just going to multiply by a square root of 3 on the bottom because then I'd have to multiply this and this by the square root of 3. Do you see it? If I multiply this by a square root of 3, yeah, that'll go away, right? But then I got to multiply this by a square root of 3, and I still have a square root on the bottom. So I haven't really helped myself at all. So what I got to do is figure out how in the world am I going to do this. I'm just going to make up a number. Just trying to make an easy number. Let's say 2 plus the square root of 5. Okay, now watch. I'm just going to show you something. And then hopefully you'll believe me, and then we'll apply the same principle down here. If I took this, 2 plus square root of 5, and I multiplied it by 2 minus the square root of 5. Now look, what's the only thing I changed? The sign in the middle, that's right. Okay, it's the only thing I changed. Everything else I kept the same. All right. By the way, we give this a name. If this is 2 plus square root of 5 to begin with, if I multiply it by 2 minus the square root of 5, if I change the sign in the middle, I call this the conjugate. So I'll refer to that every once in a while, so you'll need to know what I'm talking about. Multiplied by the conjugate. What is the conjugate? It means it's the same exact thing, except I just change the sign in the middle. Make sense? Now watch what happens when I do that. What are we going to do here? We're going to do a little distributive property, FOIL method, right? Okay, so we'll do a little FOIL. So let's see what we get. 2 times 2 is 4. And then 2 times negative square root of 5 is minus 2 square root of 5. Do you see that? And then, watch this. This is minus 2 square root of 5. What's this inside going to be? Plus 2 square root of 5. You see that? And let's keep going. Plus times a positive times a negative is negative. Here we go. Square root of 5 times square root of 5. What is that? Just in your head. It's just a plain old 5, isn't it? Now look what happened. What happened to this square root of 5? Negative 2 square root of 5 plus 2 square root of 5. What happened there? It's a 0. Adds up to 0, doesn't it? You see that? Just adds up to 0. So what am I left with? I'm left with 4 minus 5, which is negative 1. So watch what happened. When I took this, when this is a sum, all right, either a plus or a minus, it doesn't matter which one, but I've got one number plus another one, and one of those, at least one of them, is a square root. Look what happens to that square root. It goes away, doesn't it? So think about it. If this was my denominator, what would I multiply that denominator by in order to get rid of the square root? I'd multiply by its what? Conjugate. You see it? Over here, what did I multiply by? I just multiplied by itself, right? The square root of 2. And I got rid of the denominator. But if you have a situation like this, where this is either a plus or a minus, I don't just multiply by the square root of 2. What do I multiply by? Its conjugate. Now, if I do that to the bottom, I also do that to the top. Not because whatever I do to the bottom, I do to the top. That's not really a rule of algebra. But what I'm doing, if I do that to the bottom and the top, it's the same thing on top and bottom, which means it's just a 1. Right? So what am I going to multiply the bottom by? 2 plus, good, 3 square root of 3. Because you always take the opposite sign. You see it? If I took the same sign, these things wouldn't cancel out. These wouldn't add up to 0 if I took the same sign. So I got to take the opposite sign. It's the same numbers, right? But it's the opposite sign. Now, if I do that to the bottom, I do that to the top as well, because really, what am I doing? I'm multiplying by, what's that whole thing? Yeah, but what's the whole thing? Look what I'm circling. This whole thing. It's a 1, isn't it? All right, so really, I'm just multiplying by a 1. Does multiplying by a 1 change the value of it? Not at all. But what it's going to do, it's going to get rid of that square root. See up here? Multiplying by its conjugate got rid of that square root. That's my whole goal here, is to get rid of that square root on the bottom. So let's, now, it's a little bit more involved than this was, but if you know how to do FOIL method with this, you'll know how to do this. All right, so let's see what we get. Let's do FOIL method on the bottom. And after a while, you're going to see something. Look at this. See what this left you with? It left you with a 4, and it left you with a 5. What happened to the outside and inside with the FOIL method? They did what? They added up to 0, didn't they? All right, so what do you think is going to happen here? When you multiply by its conjugate, the outside and the inside is just going to add up to 0, isn't it? So why even bother even looking at the outside and inside? Would you agree? So what we can do is just take the first and the last, multiply those together. So 2 times 2 is 4. Now let's just see it for the fun of it. What's the outside going to be? It's going to be 2 times 3 squared root of 3, which is 6 squared root of 3. Then the inside is going to be negative 6 squared root of 3. So what's positive 6 squared root of 3 minus 6 squared root of 3? It's a 0, isn't it? Okay, they cancel out if you want to say that, but it adds up to 0. So the middle terms just added up to 0, just like they did up here. I'm not even going to waste my time and put that in here. I know they're going to add up to 0. When I multiply this by its conjugate, I know that the middle is going to add up to 0. What about the last term? It's negative times positive, which is a negative. 3 times 3, which is 9. Do you see that? This whole 3 and this whole 3. And then square root of 3 times square root of 3. What's square root of 3 times square root of 3? It's 3. So we'll do that next step in a second. Now, I got to FOIL the top. Let's do this a little quicker. First, which is 8. Outside. Now this time, this is not a conjugate of this, so the middle terms don't cancel out. So you have to go through the whole FOIL method. So that's the first. The outside is 4 times 3 square root of 3, which is 12 square root of 3. The inside, right here, is 2 square root of 3. And then the last is plus 3 times 3. Let's do this. I've got a minute left, so let's do this. What's this 3 times 3 going to be? That's going to be a 9, right? 8 plus 9 is 17. What's this? 12 square root of 3 plus 2 square root of 3. That's 14 square root of 3. Over. Let's see what's that going to be right there? 9 times 3. It's 27, right? So 4 minus 27 is negative 23. And you can leave your answer just like that. Now, a lot of times, though, they don't put the negative in the bottom. They'll put it out front, or, watch, if you put it out front, you actually distribute it through. This is the way you might see it written in the book. It's negative 17 minus 14 squared root of 3 over 23. I would accept either way, all right? But this is the way you'll see it in the book. Alright, let's do one more in the next video.